So law of cosines is going to be another tool that we have when we want to solve triangles. And I first want you to pay attention to what I have in the box here before I really start talking about the law of cosines. Law of cosines we can use on any of the angles in the triangle. That's all that is going on with writing it down 3 different times. But we're going to use the law of cosines to solve a triangle that is not a right triangle. If it were a right triangle, what would we do to solve a right triangle? What 2 kinds of things would we use? What's one of them? Pythagorean theorem. And what else do we have with right triangles? Right triangle trig, SOHCAHTOA. So if it is right, we're going to use right triangle trig, SOHCAHTOA, and Pythagorean theorem. If it's not a right triangle, we're going to first check, can we use law of sines? To use law of sines, we have to have one angle and the side opposite where we know the numbers for both of those. So if we do have a pair, then we will use law of sines because it's shorter and easier. Law of cosines says you can take one of the sides and square it. That is the same number that you get if you take both of the other sides, square them, add them together, and then subtract 2 times the cosine that's between those last 2 sides that you used. Or the side and the angle are opposite. So we can say, for any of them, take a side, so this time I'm looking at b squared, and square it. Get the same answer if I take the other 2 sides, a and c, square those and add them together. Subtract 2 times those sides, a and c, times the cosine of the angle that was across from the side I had over here by itself. The angle b is across from side b. Same thing for side c, and that's the one where we'd use the angle c in there. I recommend memorizing that relationship like I was just talking about it, not trying to memorize all of the a's, b's, and c's. They get scrambled. But that you have one side by itself and square it. The other side has the other 2 sides squared and added, minus 2 times those sides times the cosine of the angle between those sides. So let's give this a try on our first example of the day. So here's a triangle, and we want to solve it for its unknown parts. What does it mean to solve a triangle again anyway? What do those directions mean? What's it to solve a triangle? What, Kate?
Like find all the parts.
What do you mean by parts?
All the sides.
Okay, we need to know all 6 sides and angles. 3 angles, 3 sides. They'll give us some, but we need to find all of the others so that we have a total of 6 with numbers on them. This one, they've given us 3. So we need to figure out how we're going to solve it. So is it a right triangle? No. Well, how do you know? How do you know neither B nor C is 90 degrees? Mia? How do you know they're both acute? You're right, but how do you know? Okay.
The right angle is going to be across from the hypotenuse, and the hypotenuse is directly across from a angle.
You're kind of on the right track, but if it is not a 90-degree angle, there's no such thing as a hypotenuse. Hypotenuse is only side across from a 90-degree angle. What are you thinking, Sophie? So triangle sum means everything else has to be 78 total. So there's no way you can have 90 plus something else being only 78 degrees in there. So it would fail triangle sum. So we know B and C are acute. We know 102 is obtuse, so we know it's not a right triangle. So no Pythagorean theorem, no SOHCAHTOA in this one. Okay, can we use law of sines? Why not? Blake? You don't have to know 2 angles. What do you have to know? What do you mean by a pair?
Angle across.
You have to have at least one opposite pair, angle and side, that are across from each other. And we don't have that. The angle that we know is across from the one side that we don't know. So we can't use law of sines. That means we need to use law of cosines. And so we want to be a little bit selective how we are going to set that up. If I try to do something with C, I'm going to kind of get into a messy thing right now to deal with that, because if I don't know C and I'm trying to get that and I'm trying to use all the sides, I'm going to have to use the A, and I'm going to have two variables in there. So I'm going to choose to start off with A squared equals, because when I get over here for the cosine of the angle, I'm going to know the angle that's across from A. So that's going to be equal to the 5 squared plus the 3 squared, the other two sides squared, minus 2 times those two sides not squared, so 5 times 3, and the cosine of the angle across from this side A, which is 102 degrees. And this is where you guys are going to start helping me out here. We're going to clean that up just a little bit for what you're going to enter on your calculator. You're going to know that A squared is, we could do 25 plus 9 is how much? 34 minus how much times the cosine? 30 times the cosine of 102. And that's going to be A squared. So what am I going to have to do to get A? So we're going to do our algebra to get what it is we have to enter all in one step. So you're going to enter it just like that on your calculator to get A. And Ryan, what did you come up with for A?
6.343.
Thumbs up, thumbs down. Anybody else getting 6.343? And now I want you to store that as A, because we're going to need it, and we're going to put a box around it because that's one of the missing things that we needed to find. Okay, now I know all three sides. It's still not a right triangle, but now do I have one set of opposite sides? So now I can use law of sines, because now I can say that A over the sine of 102 equals. Now before I start using law of sines on any problem, I need to think just a little bit, because when we first started learning law of sines, we saw that it gives only acute answers. And if we need an obtuse, we have to convert it. Are we going to have to worry about that for this triangle? No, because we have already figured out that both of the other angles are acute. So it really does not matter which one we use. I'm going to choose to do the 3 over sine C. But I could have done 5 over sine B at this point. Does not matter. So let's see. A is something that I've stored, so that's a number. C is my only missing one in here. So this means that 3 times the sine of 102 degrees is equal to that A that I've stored times the sine of C. So if I divide both sides by that A that I've stored, I have the sine of C. But I want C. What am I going to have to enter on my calculator to get C? What do I have to do when I have something like this? Inverse sine. So we're going to write down exactly what we're entering on the calculator before we start entering anything. And at this point, I think I'd do that fraction template after you do inverse sine, so you can be real clear to get what belongs in numerator and denominator. 3 sine 102. And you're going to then have that divided by the A that you've stored. And that will give us angle C. So we get all of that typed in. Shawnee, you have that already? 27.555. Thumbs up, thumbs down. Is this what others are getting? Okay, so that's looking good. So let's see where we are with solving this triangle. We got A a few minutes ago. Now we have C. Oh, we're not finished yet. So how are we going to get B? Abby. Triangle sum. So first, we better store this C that we just found. And then we can enter 180 minus that 102 minus the C that we've just found. And this will give us angle B. And Anna, what's angle B going to be? All of them labeled, degrees on the angles, not on the side, everything circled. Everybody good with that one? So that's one example of what may happen with law of cosines. We could also have something like this. I've got all the sides and none of the angles. So I know I can't use law of sines. I don't have any opposite pairs. Do I know if I can just use right triangle trig on this? Is it a 90-degree angle, a 90-degree triangle? You know that? It's not necessarily drawn to scale. This one here on the left looks like x is obtuse. This one over here looks like they're all three acute. Maybe I could have drawn it where it more or less looked like a right angle in there. What are you thinking, Reed? We could do that comparison that we learned with those Pythagorean inequalities way back last semester. And it would be totally fine to do that. We don't have to. There's going to be a more efficient way we could do it and not have to do that calculation. But that would be one way that we could figure it out. We don't need to necessarily know if it is acute, obtuse, or right to start doing our work on this. Law of cosines will give us an acute answer if it's acute, an obtuse answer if it's obtuse. Law of sines will give us an acute answer no matter what. So let's look at those angles. Can you tell me anything about how those angles do compare to each other? Which one might it be nice to have law of cosines tell us, oh, this one is acute or this one is obtuse? What's the one we might not be able to figure out for ourselves? So Jimby, what are you thinking?
Find x, because if you find x with law of cosines, then we know if it's acute or obtuse. But if you do one of the other ones and find x with law of sines, then it might be one of the other.
And you're right, x is going to be the one for us to do with law of cosines, but why x and not one of the others? What's special about x?
That one could be obtuse or acute.
Or even right, why it and not the others?
Why x?
Yeah. You're definitely on the right track. You're definitely on the right track. Let's let somebody else jump in with a little more about the reasoning. Aiden. How do you know it's the biggest one? Okay, so remember, biggest angle and biggest side have to be across from each other. So we know it must be the biggest. So it might be acute, right, or obtuse, but the other two for sure are acute. So we're going to let law of cosines, we're going to use law of cosines for x, because that'll tell us for sure what x is. So we're going to set that one up then. X squared, side, 21 squared, start off with the side, is equal to the other two sides squared and added together, minus 2 times those same two sides, times the cosine of the angle between those other two sides, so between the 13 and the 10, or the angle across from the 21, which is the one that we want. Now, before we reach for the calculator, let's clean this up a little bit. Don't need a calculator yet. We're going to say 21 squared minus 13 squared minus 10 squared. And yes, some of those we could do 13 squared and 10 squared mentally if we wanted to. but that would be equal to negative, what would I have, 260 cosine x? So if I want cosine x, I need to divide by negative 260. So if I want just x, what am I going to enter? What do I have to do for x? Inverse cosine. So we're going to write down exactly how we need to enter the whole thing with a calculator. The inverse cosine of, use that fraction template, 21 squared minus 13 squared minus 10 squared divided by negative 260. And on your homework papers and on tests, go as far as this step with algebra. Write this down. I need to see exactly what are you going to enter on the calculator. Don't get partway there and say, oh, I can tell in my head what to enter. Write down what you're going to enter. And Ian, what you come up with? 131.417. Anybody else getting that? So what kind of triangle do we have? So we have an obtuse triangle. It specifically told us it's an obtuse triangle. We know the other two angles have to be acute, so we can use law of sines and just take the answer we get with that. Does not matter which one we choose to do next. But let's see, in all honesty, I'd rather work with a 10 than a 13 for some of my multiplying and whatever. So I'm going to say that now I know that 21, oops, let's store that x before we go any farther, before we get anything else in it on the calculator screen, because we're going to need it here, because I need to take 21 over the sine of x. And then that's going to equal another side, and I said I'm going to use 10 over the sine of y. X is stored. It's a number that I know. So that means 10 times the sine of x is 21 times the sine of y. And if I divide both sides of that by the 21, I have that that is what the sine of y is. So as you've been telling me, that means you will enter y is the inverse sine. Use your fraction template. 10 times the sine of your stored x divided by 21. And are we getting there? Vincent, do you have it already? And let's get it typed in. Grace, you have it already? Hopefully we'll end up with the same answers that way, but you could have done it with Z as we were talking about. Emily, you have it? Emily B? What'd you get? 20.922. How does that look to everybody? And then let's store that as y. So now how are we going to get our last angle? Triangle sum. So triangle sum, we just need to take 180 minus the x that we've stored minus the y that we've stored. And that will give us z, which is our final angle. Grace, what did you get for z doing law of sines for z? So you think you had another error in there? I was hoping we'd get the same thing and you could prove that it works, because if it should work if we don't have a calculator error. But with this many things to enter, it is easy to get them. Mia, what you get? So you did get it. You just didn't want, you were supposed to get something different from y, because it was across from a different angle. Or it was a different angle. So then when you did triangle sum, you should have gotten y. Did you? So see, she just proved for us that it does work to do it either one first. So any questions with law of cosines? Okay, I have one more example today, and it has nothing to do with law of cosines, but you are going to start seeing some word problems like this. And so we want to work our way through one of these. It's not that bad. We're going to talk through the steps on it. So I've got these cables, and first thing I've got to do is draw a picture. You're not going to get credit on these if I don't see a picture. So we're going to start off with a picture. And so I know I have a vertical tower. So there's my vertical tower. I don't need to worry about any other details. And I know I've got the ground coming along here. And I know those are going to make a right angle since it's a vertical tower. And then I know I've got some cables attached to this tower going down to the ground. So I'm going to need to draw those in. And let's see, the longer cable is attached to the top of the tower. So I've got one cable here like that, and it comes out here to the ground. And that cable is 150 feet long. And then I know I've got a shorter cable that's attached 50 feet below the top. So that's going to be right here, and that's 50 feet right there. Now, does that mean I need to just draw a parallel line to that first hypotenuse and come down to the ground? Is that what it's talking about? You're correct. It does not talk about that. What in the words say that we can't draw the picture with two parallel hypotenuses?
1 point on the ground.
Okay, it says they are attached to the vertical tower from a point, not from two different points. So this one needs to come over here to that same point on the ground. I wanted to emphasize that because every year I have several students that insist on trying to draw a parallel hypotenuse, and that's not what this problem is. Then let's see, what else does it tell me? The angle between the cables is 15 degrees. So point, kind of, where is that angle? That's going to be the one over there, right on the right? Because these are our two cables, so this has to be the 15 degrees right there. And we want to find the length of the shorter cable, so we need to find x. So for either the shorter or taller right triangle, I really don't have enough information to be able to solve something on this one. So I'm going to look at that smallest triangle that's just that top piece, the one that does not look like a right triangle. And I notice in that top triangle here that I have one opposite pair angle inside. And I'm pretty certain it's not going to be a right triangle. So I could do 50 over the sine of 15 and use my law of sines. Everybody good with that much? Well, if I'm going to do that, I probably need to label some of my other angles. So I'm going to call this angle B. What kind of angle does it look like B is? It looks obtuse, and law of sines is going to give me an acute answer. But remember, I just said we can't say, oh, it looks like it's obtuse. We have to come up with a reason for it. Can we come up with any reason besides it looks obtuse, that therefore it must really be obtuse? Dustin, what are you thinking? Has to be longer than what? How does that help me decide that B has to be obtuse, not acute? So that just says that B has to be bigger than C. If I put a C in for this top one, because the X, the shorter cable, is across from C, the longer cable is across from B. So that does say B's bigger than C, but it still could possibly everything be acute, and I've just done a really bad job drawing. Would not be the first time your teacher's done a bad job drawing, since I'm not an artist. Abby, what are you thinking?
Well,
How do you know that has to be acute? I like that idea, but convince me that this part right here really does have to be acute. If I took this right triangle, I've already got 90, so this must be acute. And then, because these two are supplementary, if I have less than 90, the other one has to be more than 90 or they won't add up to 180. So now we can continue with this. We know that B must be acute, or must be obtuse, I'm sorry. The B that we want must be obtuse. So law of sines is going to give us an acute one, and then we'll convert it before we're done. So we'll then set this up. So let's see, B and 150 are across from each other. So I'll set that up as 150 over the sine of B. I can't go ahead and use C because I don't know the side opposite it. You know, I want X, I don't know C, so I can't use law of sines with C and X yet. So now if I do my cross product, I have 150 sine 15 equals 50 sine B. Divide both sides by 50, so that's going to be sine B. And now I need you on your calculators to do the inverse sine of 3 times the sine of 15 degrees. And does anybody have that acute value for me yet? What did you come up with, Blake? So the acute B is 50.937 degrees. How are we going to convert that to get the obtuse one that we know it has to be? We need to subtract it from 180, so maybe multiply that by -1 so that it's a minus, and then do the plus 180. So our real B is going to be 180 minus that acute B. And what does that give you? Caitlin, you have that part? Not quite yet. Caleb, you have the real B? 129.063 degrees, and we probably better store that as B so we don't lose track of it. Okay, we want to get X. And I just made a reference that X and C are across from each other. So what can I do? Have an idea, Mia? So let's go ahead and get that angle C using triangle sum. It will be 180 minus 15 minus that B that we just found. Ayla, you have it? 35 point what? 0.937, that sounds good. 35.937, and then let's store that as C. Now we know all of the angles. We already had the 50 and the 15 degrees across from each other. Now we've got C, and we want the exits across from that. So final step is going to be law of sines to let us get what side X has to be. That X over the sine of this C that we've stored has to be the same as 50 over the sine of 15 degrees. Everybody comfortable with that? Okay, so what that means is X times the sine of 15 is 50 times the sine of our stored C. And so then if I divide both sides by sine of 15, x will be 50 times the sine of our stored C over the sine of 15 degrees. And once we have this, we will be finished with this problem. Got it? 380, is that what others are getting? So any questions on that? Does that make sense that that would be 113 point something in our picture? Yeah, it's shorter than the 150, so that seems to make sense. All right, last thing I want to talk about, I want you to open your books to tonight's homework problem, number 6. And we're not going to work all of this together, but we're going to talk through the strategy on it together. So you're going to have a triangle. They're going to give you the 40 degrees, the 6 and the 8. And we need to find lowercase a and the two uppercase angles B and C. So with today's lesson being on law of cosines, do I have any pairs where I could have used law of sines? Nope, so law of sines is out. Do I know if that is a 90-degree triangle? No, maybe it is. Maybe it's 40, 50, 90, but I don't know that. So I'm going to start out with law of cosines, and would everybody be comfortable that you could use law of cosines to get side A? Okay, that's not the tricky part of the problem. Once we have side A, we still don't know that it's a 90-degree triangle because we don't have the other angles in there. But we will have A and 40 across from each other, and we will know both of those. Would you agree with that much? So after we get A with the law of cosines, we're going to use the law of sines to get B or C. But we need to be smart. Which one should we do? Law of sines will only give us an acute answer, even if that angle really is obtuse. So we need to figure out which, if we can decide one out of B or C must be acute. Then we could use law of sines on that one. Or if we could decide one of them must be obtuse, that would mean the other one had to be acute, and we could do the law of sines on that other one. So I heard some people starting to make some guesses about one angle or the other. So somebody tell me what you were thinking. One of those, which one can you figure out must be acute or must be obtuse? Because we're going to use law of sines next. I heard some people saying letters. Were you just making guesses, or did you have a reason for those guesses? So Jimmy, what are you thinking?
Since B is across along this side, C has to be acute.
Okay, let me write down what he was just saying and see if that makes sense to everybody. Of those other two sides, he observed that 6 is smaller than 8, and so across from 6 was C, and across from 8 was B. So did I get that right? You said C had to be smaller than B, so therefore, which does?
C.
C must be acute. So that means that you want to then, as your second step, use law of sines for C, and you need to have this, whoops, you need to have this work in the work that you show on your problem set. Once you have that, how are you going to get B? So then triangle sum for B. And when you do this, B is going to come out to be either 90 or very close to 90, a little bit bigger or a little bit smaller. So you're going to see, maybe Miss Smith knew what she was talking about. Maybe it's a good idea that we figured that out. Any questions? Then the rest of the time is your work time.